When installing wiring for sensitive electronic equipment, the voltage to ground should be as low as possible, preferably zero. Voltage to ground refers to the voltage difference between a given point in a circuit and the earth ground. This is a crucial consideration for ensuring the proper operation and longevity of sensitive electronic devices. A higher voltage to ground can introduce noise and interference, potentially disrupting the functioning of the equipment or even causing damage. Several factors contribute to voltage to ground, and understanding these factors is essential for minimizing it. One factor is the grounding system itself. A properly designed and installed grounding system provides a low impedance path for fault currents to flow back to the source, helping to maintain a stable and consistent ground potential. This involves using appropriate grounding conductors, bonding techniques, and ground electrodes. Another factor is the presence of stray currents. Stray currents are unwanted currents that flow through unintended paths, such as the grounding system or building structure. These currents can be caused by various sources, including unbalanced loads, faulty equipment, or even external electromagnetic fields. Stray currents can elevate the voltage to ground and introduce noise into the electrical system. Another factor is electromagnetic interference, often shortened to EMI. EMI can be a significant source of noise and interference in sensitive electronic equipment. EMI can be generated by various sources, including power lines, radio transmitters, and even other electronic devices. When EMI is present, it can couple into the wiring and equipment, raising the voltage to ground and causing malfunctions. To minimize voltage to ground, several measures can be taken. Firstly, it is essential to ensure that the grounding system is properly designed and installed. This includes using appropriate grounding conductors, bonding techniques, and ground electrodes. Secondly, it is important to identify and mitigate any sources of stray currents. This may involve balancing loads, repairing faulty equipment, or shielding sensitive circuits. Thirdly, it is crucial to minimize electromagnetic interference. This can be achieved by using shielded cables, filters, and other noise reduction techniques. In some cases, it may be necessary to isolate sensitive electronic equipment from the electrical system. This can be accomplished using isolation transformers or other isolation devices. Isolation transformers provide a galvanic isolation between the input and the output circuits, preventing the flow of ground currents and reducing the voltage to ground. It's important to understand the role of common mode noise. Common mode noise is a type of electrical noise that appears equally on both conductors of a balanced circuit with respect to ground. This type of noise can be particularly problematic for sensitive electronic equipment, as it can be difficult to filter out. Common mode noise can be generated by various sources, including power line interference, radio frequency interference, and ground loops. Ground loops occur when there are multiple ground connections in a circuit, creating a loop through which current can flow. This current can create a voltage difference between different ground points, leading to common mode noise. To minimize common mode noise, it is important to use balanced circuits and minimize ground loops. Balanced circuits use two conductors that carry equal and opposite signals with respect to ground. This helps to cancel out common mode noise. Minimizing ground loops involves using a single point ground or star ground configuration, where all ground connections are made to a single central point. Furthermore, consider the use of dedicated circuits. Dedicated circuits are electrical circuits that are used solely for sensitive electronic equipment. These circuits are typically isolated from other electrical loads and are designed to minimize noise and interference. Dedicated circuits can also provide a more stable and consistent voltage to the equipment. When installing dedicated circuits, it is important to use high-quality wiring and components. This includes using shielded cables, isolated ground receptacles, and surge protection devices. Surge protection devices can help to protect sensitive electronic equipment from voltage surges and spikes. Regular inspection and maintenance of the electrical system are also crucial for minimizing voltage to ground. This includes checking the grounding system for proper connections, testing for stray currents, and inspecting for any signs of damage or deterioration. By taking these measures, it is possible to minimize voltage to ground and ensure the proper operation of sensitive electronic equipment. The ideal scenario is to achieve a voltage to ground as close to zero as possible. This provides the best protection against noise and interference and helps to ensure the longevity of the equipment. When specifying equipment, it is good practice to include the requirements for a low voltage to ground. This helps to ensure that the electrical system is designed and installed to meet the specific needs of the equipment. Proper grounding and bonding are essential for electrical safety and for the proper operation of electronic equipment. Grounding provides a low impedance path for fault currents to flow back to the source, which helps to trip circuit breakers or fuses and prevent electrical shock hazards. Bonding connects all metal parts of the electrical system together, which helps to equalize the voltage potential and prevent electrical shock hazards. The National Electrical Code, often shortened to NEC, provides detailed requirements for grounding and bonding electrical systems. These requirements are designed to ensure the safety of people and property. Following the NEC requirements is essential for minimizing voltage to ground and for ensuring electrical safety. Consider the use of appropriate surge protection. Surge protection devices, often shortened to SPD, are designed to protect electrical equipment from voltage surges and spikes. These devices can be installed at the service entrance, at the panel board, or at the point of use. SPD work by diverting surge current to ground, which helps to prevent damage to sensitive electronic equipment. There are several different types of SPD available, each with its own advantages and disadvantages. It is important to select the appropriate SPD for the specific application. Regular testing of the grounding system is also important. Regular testing of the grounding system can help to identify any problems or deficiencies. This testing can be performed by a qualified electrician using specialized equipment. The testing should include measuring the ground resistance, checking the continuity of the grounding conductors, and inspecting for any signs of corrosion or damage. Based on the equipment in use, one should evaluate the grounding and shielding needs. Proper grounding and shielding are essential for minimizing noise and interference in sensitive electronic equipment. Grounding provides a low impedance path for noise currents to flow to ground, while shielding prevents electromagnetic interference from coupling into the equipment. Shielded cables and enclosures can be used to protect sensitive electronic equipment from EMI. Proper grounding techniques should be used to ensure that the shielding is effective. It is crucial to consider the power quality. Power quality refers to the characteristics of the electrical power supply, such as voltage stability, frequency stability, and harmonic distortion. Poor power quality can cause problems for sensitive electronic equipment. Voltage fluctuations, frequency variations, and harmonic distortion can all disrupt the operation of the equipment. To improve power quality, it may be necessary to use voltage regulators, frequency converters, or harmonic filters. Also, ensure that the wiring is properly installed. Proper wiring practices are essential for minimizing voltage to ground. This includes using the correct wire size, properly terminating connections, and avoiding sharp bends in the wiring. Loose connections and damaged wiring can increase resistance and create voltage drops, which can contribute to voltage to ground. It is also important to separate power and signal cables. Power cables can generate electromagnetic interference, which can couple into signal cables and cause noise. Separating power and signal cables can help to minimize this interference. In some cases, it may be necessary to use shielded cables for signal cables to further reduce interference. Furthermore, consider the impact of lighting. Lighting can also contribute to voltage to ground. Fluorescent lighting and LED lighting can generate electromagnetic interference. Using shielded lighting fixtures and filters can help to minimize this interference. It is also important to ensure that the lighting is properly grounded. Static electricity can also be a source of problems for sensitive electronic equipment. Static electricity can build up on surfaces and discharge into the equipment, causing damage. To minimize static electricity, it is important to use anti-static materials and equipment. Anti-static mats, wrist straps, and sprays can help to prevent static electricity from building up. Humidity control also plays a key role. Humidity can affect the performance of sensitive electronic equipment. High humidity can cause corrosion and condensation, while low humidity can cause static electricity. Maintaining proper humidity levels can help to prevent these problems. Depending on the equipment, one might need to consult with a qualified electrician. Working with electrical systems can be dangerous. If you are not qualified to work with electrical systems, it is important to consult with a qualified electrician. A qualified electrician can help you to design and install a safe and effective electrical system for your sensitive electronic equipment. Also consider the importance of regular maintenance. Regular maintenance is essential for ensuring the continued performance of sensitive electronic equipment. This includes cleaning the equipment, checking connections, and testing the grounding system. Regular maintenance can help to identify problems before they become serious. Lastly, document everything. Maintaining detailed documentation of the electrical system is important. This documentation should include the wiring diagrams, grounding system layout, and any test results. This documentation can be helpful for troubleshooting problems and for making future modifications to the electrical system.